Welcome. So I'm happy this morning to be doing a very concrete talk. Maybe you have heard me a few times doing more community stuff or vaporware talks about what we could do in the distant future. And this is really very concrete for once. You have the code. You have the URL here for the code. It's in the Sling Whiteboard, so you can follow along. I think some of you have computers, so you can take advantage of that. So my name is Bertrand Delacretaz. I'm come from the French-speaking part of Switzerland. I work for Adobe in the Basel office on the core of Sling. Actually, with Carsten and Felix Meschberger, we were at the very beginning of Sling, almost 10 years ago. We probably have to do a party at some point. And I'm also I'm on the Sling PMC, obviously, and I'm also quite involved in the Apache Software Foundation on the board of directors. So also on the community side of things. But today it's really a technical talk. So as I said, it's in the Sling Whiteboard, so you can get the full code. It's pretty small, but you can follow along and play with it and maybe expand it. Apache is welcome. So what is Karate? Who has already played with Karate? Karate, the HTTP testing tool, not the martial arts. Anyone? Not much. Good. So you will learn something. Good thing you came. Karate it's a testing tool. The tagline is web services testing made simple. Basically, it's meant to test HTTP APIs, HTTP interfaces. It's very efficient to write. We'll see the example on the next slide in more detail. And I would even say it's fun I don't know about you. I like writing tests. I wrote a large part of the Sling integration test suite in the past. You can look at those tests. That's real old code now, but we're still finding bugs thanks to it. So it's useful. So I'm a test freak, I would say. I like doing test-driven development, and I think that's when you have such a comfortable and friendly language and expressive, it's very useful. It was created by Peter Thomas of Intuit and open sourced a bit more than a year ago. And if you look at the commit stats, Peter has been doing the vast majority of the commits. So you could say it's a one-man show, or you can say join in and come and contribute. So it's pretty stable. It's totally, even though version number is 0.8, it's not too bad. And Peter has been, in the last few weeks, rewriting the parser of the language and the execution engine to move away from Cucumber. Currently, it's based on Cucumber and Gherkin, and he's rewriting that to be independent because it doesn't. I don't think it brings much. It was probably a way to get started. Unusually for an open source project, I'm a bit ashamed of saying that, but the docs are fantastic. It's not always the case, as we know, in open source and even in commercial. But the docs are really good. So you have this. If you just go to the homepage of the Karate project, and you have this index which points to all the important things, and there's also a large set of demos that are pretty focused on specific items. So, in my opinion, very, very useful demos. A good example, I think, of how to do a documentation. The scope of the project is not huge, which also helps. It's easier to do good docs if the scope is clearly defined. But I think that's a good thing for a software project anyway. So, how does it look? This is a simple test with Karate. So a test is in a feature file, that's a text file, in a DSL, domain-specific language, that they defined. The test is organized in scenarios, and scenario is one unit of testing, where if you have to keep state, that should be in the same scenario. If you're creating content and then retrieving it, do that inside one scenario. But you can have many scenarios in one feature file if needed. And then the pattern is that you define a URL. Usually you will define like configure a base URL, and then you just define the path. It's easier, depends on what you're testing. And then you define your request, what attributes does it have, what parameters, what body, what content, what headers. Then you do a request, when method post here, and then you can analyze the response. What's the status, what's the content of the request. So, it's not rocket science. If you have to test an HTTP API, you would do it like that. But if you compare that with the old tests, integration tests that I wrote for Sling almost 10 years ago, it's a different world. This is so much more expressive and easy to write and everything you want. And then here we have a second response. So you can do multiple calls and request response and so on. And Karate provides all the nice tools to set up your request, define how the request looks. And also for the matching, you would see that it's pretty powerful. And it's also extensible. You can also use any Java class if you need to do exotic stuff. So I think for my angle in using Karate is that I like to use tests as reference documentation. If you look at the Sling documentation, in many cases we are giving you the overview, and then we tell you, look at the test for the details. And if the test is readable, I think it's a great principle, because you know that the documentation is, you know that the test is right if it passes. So it allows you to keep your documentation in sync. And I think my idea, and I'm starting to do that in my projects at work, is to use Karate to describe and document the HTTP APIs that we're creating for services. So this is this diagram. So today, if you're creating services, then the key is as always, the keys in software, the key has always been to have good interfaces. In this case, the interface is the HTTP Service API. And then the clients, today is not just browsers anymore. You very often have machine clients, so your HTTP API needs to be very stable and well documented and extensively tested, so it's very stable. And then the machinery that you have behind the test, that can be mysterious or old or unstable or starting. It doesn't matter that much if you can have a stable interface and then improve the services over time. So I think that we should really put the effort on defining and testing these APIs very strictly. So with this in mind, I've created this small set of examples in the Sling Whiteboard, the links that I was giving you before, where I think, for example, taking the example of the Sling post servlet, which is one of the key elements in Sling to manipulate content, and how we can test it and document it in the same time using Karate. So here you see a simple example where you're creating a resource. You have the path of test folder, you add a star, and then you do a post on it with some form fields, and then here you see how you can read the response header location, because that's how Sling tells you where the resource has been created. And then using this value, you do a get on the resource that you just created, and you check, using the Karate matching language, you check the values in the response. All pretty straightforward, but I think it's cool. You don't need to read tens of pages of documentation to understand how this works. And you can use this as an example then to create your own tests. So let's dig into this a bit more. So I'll show you now the set of tests that have been created. It's only like 4 or 5 tests, but they show some important features of Karate. That's the idea. So I'm using this as much as it's more like examples than testing, to validate my concept of using this to define and document an HTTP API. So here's, this is a basic structure of a Karate test in a bit more detail. At the top, you have tags with the @ These are simply used to group the tests in families. So then you can run some specific tests by giving the tags, the tests that have to do with images, or the ones that have to do with post servlet or security, whatever. The usual tagging concept. Then the feature, this is the name of this feature file. So you define what it does. Karate will use that for the repos that it creates. And then the background section is where you define the environment, the context of your tests. So here I'm defining the URL to be the base URL, which is defined elsewhere in the Karate config. I'll show you that then when we look at the code. Then I'm calling a JavaScript function that Karate is going to look for in the class path. And this is just used to configure the headers for the admin credentials that I need for my tests in this case. Then I'm calling another Karate feature, which is used to find out if Sling is ready to run the tests. I'll show you that as well. But so you can call JavaScript functions, you can call other Karate features, so modularize your test and so on. And then I'm using here I'm showing access to a Java class, also very straightforward, to create a unique test ID for my tests and then compute a folder path based on that. So this is the background I'm setting up for my test. And this is pretty also straightforward and you will do it. But Karate allows you to modularize that so you don't have to repeat all the details every time. The common way of having clean code. This has a bit more details on the testing the post servlet. So on the left is the example that I already shown before. It's the same thing. So creating a resource with a post with a few form fields, using the location header to find out where the resource was created, adding a .json extension to trigger the Sling JSON servlet, do a get, verify the HTTP status, and verify here we are. Response is a JSON object that we got back from the server. So Karate is verifying that it's valid JSON, parsing it, and so on. And then you can access it using typical JSON path notation, using variables as well. So quite it's quite obvious when I show you when you show it like that. And I think it's cool. It means you don't have to scratch your head a long time to write these tests. And then in the second part on the right side, I'm doing a post on the same request, on the same resource, changing the value of one field, and then I'm doing a get and validating all the three fields that they have the value that they expected. I think if you add just a few comments to that, it can be a good documentation of how you create content with a Sling post servlet. And that's the idea. Because it's very readable, and you could show that to someone who has no clue about Karate or about Java or about Sling, whatever, and they would understand. If they know HTTP, they would understand how this works. Here's a slightly improved way of checking the responses. So Karate on the right, you see the templating mechanism that's used to define JSON structures. So I'm defining a small JSON objects with three fields, using variables, test ID in brackets with a hash. That's a variable that I computed before based on Java UID class. So you can create JSON using this templating language. And here I'm using it to test the Sling post servlet import operation, where you import a block of JSON into the content repository to create content. So you see that I can say simply form field :content equals my JSON, and Karate does all the right thing to send that with the correct encoding and whatever to the server. Doing a post, I get a status 201 created, and they're using the same pattern that in the previous test. I'm checking the resource. I'm getting the resource. Note how you build the path, just comma, parent folder, comma, test ID. Karate takes care of putting the slash if needed or not, the thing that you had to do in a very boring way if you do it in low-level Java. And then, also interesting, I'm matching $. $is an alias for the response. I'm matching that $ equals new content. And it's actually a match. So Karate doesn't care if you reverse the order of the fields, for example, in the JSON, it's still a match. So the match is not complete equality, it's semantic equality. So this is very useful. So on the surface it looks very simple, but if you think about all the small things that had to be implemented so that it works like that, I think it's pretty cool. So it's kind of the beauty of simplicity with all the good machinery behind it to make to make it work. The next example is uploading an image. And here you also see a very simple way of setting the image to upload. You can just say multipart field file equals read the file from the class path. Pretty cool. Same thing, Karate does all the mechanics of putting that in the right format. And you can also do the here I'm also matching the response.file is not the image itself, it's the metadata of the file. So I'm also matching to a JSON structure. I think that's the same as on the previous slide. Anyway, but it's also a JSON structure that was created with this templating system. Here we see a bit more detail on this matching of JSON. It's actually, it's not JSON schema, but it's similar to a schema. Karate can use a number of markers, they are listed here, in the JSON templates to do fuzzy or more or less fuzzy matching on the JSON that you get. For example, here I'm saying, yeah, this is the metadata that I was checking in the previous slide. Okay, JCR primary type, I want it to be an entity resource. MIME type, application octet stream, that's fixed. But last modified by, I'm just checking that it's a string. I don't want to go to my test to be too brittle. And same thing for last modify. JCR data, Sling gives us the length of the file, so I know it. And UID, I'm also checking that it's a UID pattern. So that's extremely useful. And you can use Karate expressions as well, so you can go to JavaScript or delegate to Java classes to do matching. So you can do more sophisticated matching if you want, but you have a set of markers which are very useful, like Boolean, number, string, and so on. And then you can use this match. So although it says equals equals, again, it's a somewhat fuzzy match that makes total sense in our context of testing APIs, HTTP APIs. And you can even match the image, the binary image itself. Here I'm getting the file /JCR data, which is the actual binary data of the file. And you can just match it, match response equals reading the file from disk. So you can do an exact binary matching. Don't use too big images to do that if you want your test to run in a reasonable time. But it works quite well. So again, simplicity at the forefront. So I think, there's one test that I haven't shown yet that comes later. But you see, in my example in the Sling Whiteboard, I have 4 test features. One for importing content. We saw that, where you import a JSON block. One for creating content, where you do post and get on the post servlet. Initial content we haven't seen yet. I'll show it later. And upload image, we saw the core of it. So these 4 feature files, they are the actual tests. So of course you want to write them. And then the rest is boilerplate. The rest is helpers and stuff. But it's pretty small. There's one JUnit test, the Sling-test.java, which is used to proxy JUnit, to proxy Karate to JUnit. Tells JUnit to run the Karate test. It's 0 actual lines of code. It's it's like 4 lines, and none of that is code. It's just annotations and stuff. You can see them. It's very easy. There's another one, the post-servlet simulation.scala, which is about 30 actual lines of code. That's for Gatling performance tests. I'll show that later. But there's also a proxy where you can reuse your Karate features to run Gatling performance tests. And I think that's very useful. And maybe I need to talk to the Tough Day guys to also do something there that might be interesting. And then I have a few utilities. We saw that. One that computes the auth headers for admin, one that tests if Sling is ready, clean up path at the end of the test, and so on. They are very small things, of 3, 4, 5 lines of code, so it's not big either. And then they have some test content, my image, and then configurations. You have one Karate config file that is a JavaScript file, so you can also do interesting stuff in there if you need, like switching between environments, staging, production, and so on. AdaptTo test for that. And a config for the logback, so for the logging that Karate does when you run the test. So there's not much. It's really heavily dominated by the actual tests, and that's a good thing. You don't need to to have much boilerplate. So I'll show you now as a demo how you run the test. It's not very impressive, but you will see what tools are available. So basically, what we'll see, you can run the test with Maven, nothing special. They just run via this JUnit proxy class that I mentioned. Karate provides some nice HTML reports of the test where you can see the actual responses, so it's very useful to look at the details or troubleshoot. We also see the Gatling performance reports, and Karate also has a small UI, which is pretty basic, but it is also useful to debug, troubleshoot the test. So I'm going to show this right now. Just need to switch my display. Here we go. So first, running the test. Can you see that in the back? More or less? I can make it bigger. Yes. It's not, you don't need to see the details. It's just basically the shape of it that's interesting. So it's just very boring running JUnit test, nothing special. But Karate then points you to the report, to the HTML reports that it creates for each feature. And then let me show you one of these reports. Here. So you get a list of all the tests that passed in your scenario. Here I have 51 tests. And then the things in blue here, you can click the method get, for example, and you get all the dump of the important parts of the request response. So very useful to troubleshoot, including response time. So you can, it's very, very useful information. So this is produced by Karate when I'm running the test with JUnit as usual. A second demo. These are not very impressive demos, but I have to show you how the tool works. The second thing, I'm running Karate specifying a tag. So before that, we run the 4 features that I created. We see that, 3, 4 here. And if I say tags equals images, then it will run just the image upload test that I created. Nothing, not rocket science, but allows you to select the set of tests. And I have a tip and trick. I haven't been using Karate for a long time, but I have already one tip and trick for you. I set an @current tag on the test that I'm working on, and then you just run the @current and can debug it easily. Another thing that I'm showing now is running the Gatling test. So you can, as I mentioned, you can use the Karate feature test that you have created as Gatling performance test. I think it's useful because you don't have to rewrite them. I don't know if they're optimal, or maybe you would tune the test a bit differently or write them a bit differently if they're for performance, but I think that's a good tool. So you also run this from Maven with the Gatling plugin, and then you get also an HTML report of the tests that I'm going to it's a bit slower because it's Scala, and I have an old computer, but you get an HTML report at the end, boom, where you see the usual Gatling, response times, average, min, max, and so on. And maybe I'll show you the proxy for that while we're here, because there's one thing that's interesting in there. If I can find it. So Sling Whiteboard here. Let me just get that test. So maybe I have it on the slides, I forgot. But anyway, you will have seen it this way. In the so the Gatling, there's a small bit of Scala code to proxy Gatling to Karate, which it's simple. It's not really code, it's more declarations. But what's important in there is this part on the top, where you group your tests, because in my tests I'm using a unique folder ID for each test as isolation, because you can also run the test multi-threaded. I didn't do that here, but you can. Here we're grouping the test based on the path so that the Gatling report makes sense, so that you don't get 1,000 lines in this Gatling report, but each line is a specific operation or specific, each line pretty much maps to a specific test. If you didn't have this aggregation, then you would get tons of lines in this report. So this is running the Gatling performance test using the same scripts. And I'll just run the last test. This is something else that I'm showing right after this. Karate also has a very nice feature called test doubles, where you can use the same language to define, to mock an HTTP service. So you can create a fake HTTP service. If you're doing test-driven development of HTTP APIs, you need mocks for the HTTP services. You don't have the service yet, but you're creating the test that defines its API. And Karate allows you to use the same language to create a fake server, fake HTTP server, which implements your API. So I'm running it here, also not very impressive, but just to show that it's starting, it's the feature server class is starting my server using the Karate feature language. So this is the demo. Not very impressive, but I think it's cool to show that it's simple to run things. I'll switch my display again. Did it wrong. User separate. So this, I think at this point we've seen all the basics. We've seen how you write tests, pretty much what you can do in them, the extensions using JavaScript or Java. But there's a few additional features that, okay, some of them were already mentioned in the demo. So the Gatling tests, yeah, I have it here. So here I have the gist of this proxy, aggregating the path on the top so that you don't get too many lines in the Gatling report. Then defining which Karate features you want to use as performance tests. You don't need to use all of them. You specify the list here. And then you can define the Gatling performance profile, load profiles, how many users, sorry, something is interfering, how many users you have in Gatling and how much time you take to ramp up and so on. And you would see the details in the Gatling report. So again, it's not really, it is Scala code technically, but it's just a few declarations. Another thing that I didn't show, this is this initial content test that we skipped before. It shows how you can use data-driven testing in Karate. So here I have a table of values with 3 columns, content path, JSON path value. I'm using this to test that the Sling instance has the correct initial content. So for example, testing that at system/console/bundles, I get JSON object, and the data is an array. The first element, dot symbolic name, is org Apache Felix framework. So you can do table-driven like that, and then it runs the test n times, one for each line of the table. So very, very useful way of having data-driven testing. And then this is the test doubles. So the thing that I mentioned where you create a fake server, using the same language as a Karate feature. And here, for example, we have this example where if the path is cats and an ID, and the accept header contains text/XML, then I define my result. I have a cats array or map where I have that data. If I don't have the data, I abort with status 404. This is a function that's higher in the script. And then I'm generating XML. This is another, you can also template XML in Gatling to either as a request or response. So this is also another useful thing. So you can see all the details in the Sling Whiteboard for these test doubles. And there's also not much code to run them. The JUnit class that does the proxying is a bit more complicated, but still very simple. So it's this is not in the Sling Whiteboard, but if you go in the Sling Whiteboard on the Karate HTTP testing module, there's a link to this, which is in my own GitHub repository. Because it's a minimal project, I'm showing what you need minimally to run these test doubles, and it's really small. So that's it. I hope to have convinced you that Karate can be very useful to define and test HTTP APIs. Of course, it's a DSL, so it has limitations. If you need to do very exotic testing, maybe you can't do it with Karate, or it doesn't make sense. But because it's run with JUnit, you could very much mix and match, having more complex JUnit Java tests and Karate for all the basic stuff or all the not really basic, but the HTTP API definition, I think, makes a lot of sense. I'm only here until tonight, but I'll be at the, how's that called, the playground session on testing this afternoon. If you want to discuss much more, I'm happy to do that. Don't know if you have 1 minute for questions, or we have 1 minute for questions. So it needs to be an excellent question to use this one. No, I'm embarrassing people, sorry.
You quickly showed that you can run a karate as a mock-up server.
Yeah.
And you mentioned it's the same syntax. Can you reuse the same test, or do you have to write separate ones?
No, you use the same test. So the client test is exactly the same, and then the mock-up server, it's different because it has a different purpose. It's I can show it. You need to write the interactions of the server. So matching the incoming request and deciding what to do with it. So the mock server is a different, it's the same syntax, but it will be a different feature file because it has a different role.
I was wondering if it could use the test descriptions to provide a mock-up server.
To generate the mock, yeah. No, I see
and then
you
can write your client code that you write against that mock-up server.
Right. No, so there's no generation of the mock-up server.
Okay.
Patch is welcome.
Thanks.
Yeah.
Thank you, Bertrand, for your talk.
You're welcome. Thanks.
Thank you very much.